And the heterozygosity is in fact a reflection of that top graph, so you get the same similar result. There is one natural population, the Norwegian population, that shows lower genetic diversity than the other populations, but that is a fairly isolated population in a fjord, so there is probably less connectivity with other oyster populations. Then if we look at the family structure, it's really small for you and also for me to see, so that's why I brought this, so I can read what you can't, hopefully. Let me get the right paper, which is already a challenge with my wrists, but it works. So the results you see on the left-hand side of the graphs is the number of unrelated species. Then in the middle you have the unrelated individuals, Then you have the half-sips in the middle, the half-siblings, and the full siblings on the right. And the graph on the right bottom is a natural population, so all of the individuals are unrelated, and the other other five are the hatchery populations. And then I would like to point your attention to hatchery number 5, which has a lot of related individuals in a hatchery compared to a wild population. And this can also vary among hatcheries. Here we compare two different hatcheries, and one has much less, shows much less relationship than the other one. And they used a higher number of maternal oysters in their larval production tanks. And they also use fresh broodstock yearly. And yeah, that's it. Yeah. So then, this is really not readable to any of us, but I just wanted to point out that we are working on a decision support tool for restoration. And there it is good to go through different steps. So you have the planning step, you have the source material step, and you have the genetic monitoring. So in the planning, you really need to know if there is a local oyster, what is the genetic characterization of your local oyster. And if you are not using your local oyster and you're going to source your oysters from another location, then you need to also know the genetic diversity of that location. And if you go to a place to restore the oysters, you first need to check if there are any oysters left and what is the connectivity of your location to other locations. And then when you have answered all these questions, you can then decide to either use local or import oysters, and they can be hatchery produced or they can be wild. And that can all have an effect on the scale of the success. So in the end we came up with some recommendations, which I have summarized on the next slide, so you can read them again. The recommendations are to use locally sourced, hatchery-produced oysters, originating from the same regional background, and ensure sufficient genetic diversity so that you can maintain the genetic variation within the hatchery stocks. But it's also important to monitor and assess the genetic diversity. And if you select broodstock with potential disease tolerance, then you can also prepare for the future, because perhaps if you think about the North Sea, restoring oysters in the North Sea, perhaps the restoring disease will end up there, and then if you have disease tolerant, and the individuals will end up there, and then if you have disease tolerant and individuals. And final recommendation is to develop a structured breeding program to. And final recommendation is to develop a structured breeding maintain or enhance genetic diversity. And to promote the tolerance and maintain or enhance genetic population resilience, and to promote the tolerance and overall. Thank you for your population resilience.
Hi, Pauline. Thank you very much. Illuminating as usual. Hi, Pauline. Thank you very much. Illuminating as usual. In the interpretation of these data, particularly, it would be very important in the interpretation of these data, particularly, provide an understanding of what has happened to that specific stock. In a natural understanding of what has happened to that specific stock, you may have multiple in a natural production and through grading season, and you have multiple spawning. Several spawning through grading you tanks end up enhancing the diversity several spawning from several broodstock tanks. But if indeed in one of these diversity of there was a specific intent, but if you separate one of these broodstock, there was a specific intent to separate the small number of broodstock generation from that particular broodstock population. Do not mix. You may end up with a generation from that particular compared to a commercial hatchery that is. You may end up with a maximizing opposite numbers compared to a commercial hatchery that is morphological maximizing numbers, and so it would be important morphological similarity what the process of the stock has been. So it would be important to describe what the process of the stock has been give, because it can be radically about the relatedness of the oysters being produced in any specific hatchery.
Yeah, that's a good point. And you did see in the results I just presented that there are differences between hatcheries that are commercially producing oysters for the consumer and not for restoration. Yeah.
Thank you, Pauline. Great work and very interesting and important for us. Can you go back to the slide with the recommendations? Thanks. So, me not being a genetic expert, but just sort of your client and what to do when restoring oysters in the wild, and in Germany the special situation that we have no oysters left and we have to start with some broodstock. I was wondering, I agree with all your points you mentioned here, but then two of them are not easy to handle in combination, because on the one hand we have to take care of the genetic diversity, and on the other hand you recommend breeding disease-tolerant oysters. So what is your suggestion of how to address these two opposite directions?
I don't think it's really opposite. You can have disease-tolerant oysters that are genetically diverse. So I'm not sure if I understand your question.
Yeah, I'm sorry, maybe my fault. I was wondering how many disease-tolerant broodstock oysters or sources do we really have in Europe?
Yes, yeah, no, I understand better. Yeah, well, as far as I know, we only have two areas. We have the Irish area where the oysters have survived bulimia for a long time, and the Dutch area. So yeah, that is a good point.
Thank you. Thank you, Pauline.
But I don't have an answer yet.
But we can think about it,
yes,
and speak about it later. Thank you. I think we need to go on, and now I invite Céline Gamble to speak about the Wild Oyster Project. It will be the last talk of the session, or the first part of the first session, sorry. So Céline, the floor is yours.
Hello everyone, my name is Céline Gamble and I'm a project manager based at the Zoological Society of London, and today I'll be presenting our Wild Oysters project as a follow-up on our restoration activities and oyster spawning methods and results. So today I'm presenting the results on behalf of our wild oysters team, who are all here today, including Ashley and Ben from Groundwork North Eastern Cumbria, Maria and Ree from Bangor University as well, and what I'm presenting is on behalf of the team. So the Wild Oysters Project was set up in 2020, and we set up restoration hubs located in the northeast of England in the Tyne and Wear and North Wales in Conway Bay. Both locations have no remnant native oyster populations. Our key activities have been to develop a seabed restoration plan and deliver seabed restoration activities, and also set up broodstock oyster nurseries in marina locations in both sites, and also deliver an outreach and engagement program in marina locations in both sites. And in both sites, we're working with and also deliver an outreach and engagement working group to drive the development community as well. And in both sites, we're working with key. So as I mentioned, we've got the marina locations with the oysters in them. So in Sunderland Marina, we've got. So as I mentioned, we've got the marina locations with the oysters in them. So in Sunderland Marina, we've monthly monitoring of these nurseries for about 4 years now, and also that's led by by Ree in Wales, and then monthly monitoring of these nurseries for about 4 years now. That's led by by Ree in Wales, and volunteering hours, and the data that they're helping us to collect, and we've had support from over 1,000 survey data so far, dedicating looking at mobile species in nets, and also the data that they're helping us to collect include and also biodiversity survey data as well. We've seen an average yearly species in nets, and also the sessile species living on the shells themselves, and also we also look at the larval distribution of those oysters, so looking at additional summer monitoring to investigate the reproduction and assess broodstock success. So as I mentioned, we've been doing larval monitoring each summer, and also recently we've introduced plankton monitoring trials this summer as well. So here in the background, you can see a video of Maria, who's leading a larval monitoring session with a group of volunteers. So I'm just going to talk through our methodology. So, as I mentioned, we've been monitoring the spawning activity weekly over the summer months at both the Conway Marina and Sunderland Marina. We take a random subsample of at least 20 oysters, which were anaesthetised non-lethally using a 5% magnesium chloride solution to relax the abductor muscles. And then the internal cavity was checked for larvae, looking at the different development stages identified by the different colours of sick. So if present, larval samples were collected and preserved using Lugo's iodine and analysed as soon as possible. So if present, larval samples were collected and preserved using Lugo's iodine and analysed as soon as possible to get an estimate of the total oyster fecundity and number of oyster larvae produced per oyster. And this has been led by Maria at Bangor University in the Bangor University laboratories. And once preserved, we used 1 mil, once preserved, 1 milliliter was extracted and diluted in 99 milliliters of water, and a 1 mil aliquot of this 1,000 milliliter solution was then placed on a Cedric rafter. Temperature plays a key role in when we start to observe oyster larvae at each site, and across all 4 years, the larvae appeared at lower temperatures in Sunderland at around 14.7 degrees, compared with around 17.1 degrees in Conway in Wales. To understand spawning timing a little bit more, we looked at degree days to reflect the total accumulated heat above the threshold needed for gonad development, and looking at the temperature sum from the 1st of January was compared to the larval counts, and spawning typically began around 404 to 554 degree days. And what we start to see in our data is a shift from when we start to see that threshold being reached. So in Sunderland, oysters have been spawning later each year since 2023. We've been seeing the spawning earlier since 2024. Overall, this shows how sensitive the oyster spawning is to temperature and how just small differences in local conditions can alter reproductive timings across the sites. Across the monitoring period, larval abundance varied widely, between 22,500 to 6.1 million larvae released per oyster. Monitoring period, larval abundance varied widely, between 22,500 to 6.1 million larvae released per oyster. And when we look at the yearly trends, the average larval count per oyster has actually declined each year, with a 45% reduction in Conway and 65% reduction in Sunderland between 2022 and 2025, which you can see in figure 2. Next, looking at the effect of spawning on broodstock mortality, We compared the monthly mortality rates with the number of brooding oyster larvae from May 21 to July 2025. And spawning wasn't actually monitored in 2021, but we expect that the high mortality that year reflects the acclimatization after we did the initial stocking of the oyster nurseries. And you can see that the mortality peaks during the summer spawning season consistently coincide with brooding activity, with the highest mortality peaking. So move on to the discussion of our larval monitoring. So the reduction of breeding oysters doesn't indicate a healthy or growing population. However, in the marina sites themselves, we've observed spats settling on the broodstock oysters, and in some cases we've started to see the formation of clocks where 3 or more oysters are becoming adjoined. And that does indicate some level of local recruitment in the marina location. And as expected, we found that temperature influences the reproductive potential indirectly by potentially affecting the sex ratio. So with the warmer temperatures, it could have led to more oysters remaining male, although we weren't assessing sex ratio as part of this study, which found the presentations yesterday afternoon quite interesting for us to look into. Obviously, the marina locations themselves are which found the kind of a sheltered environment operating with range, which could lead to some level of stratification and reduced food supply. A sheltered environment operating with tidal gates restricting the water exchange, which could lead to some level of stratification and the timing of food supply, the larvae in the marina. And together these points have been helpful in planning our plankton larval monitoring and learn more about the oysters that might be brooding on the larvae in the marina. So this brings me on to our plankton for larval monitoring methodology, which is led by Dr. Ashley Tinley-Mackenzie in collaboration with Newcastle University that we've recently introduced to the North East site this summer. And the aim of this is trying to better understand whether the larvae from the broodstock in the marina location is reaching the restoration site. So here on the slide you can see a map. There is an orange circle which shows the broodstock location of the marina, and the black dots show the plankton sampling stations with the yellow arrows on them. So these stations were selected based on our larval plume modelling that we did, and the blue shading behind shows the outputs of that model, and with the darkest areas indicating the highest level of predicted larval abundance. And so we completed field sampling using the 4 sample stations along the larval plume for that, and then sampled 3 times during the spawning season. We did 3 vertical tow replicates using 100 micron mesh plankton net at each station, and then after that the plankton was rinsed with deionized water and fixed in 96% ethanol and frozen. After this, collaborating with Newcastle University, we're looking at the morphology. So we're using a plankton scope to summarise and photograph the bivalves collected from the plankton sampling. So all bivalve samples are removed from the plankton sample for further investigation. And then we're also using genetic coding, looking at the native and Pacific oyster tissues within that sample. So overall, we're trying to, went ahead there. So overall from that, we're trying to basically understand if the oysters brooding in the marina sites are reaching, the larvae reaching the reef. So on to some of our restoration activities. So this slide shows a summary deployment of scallop shell and stone deployment in an exposed coast environment, which is around 10 metres water depth. And stone deployment in an exposed coast environment, which is around 10 metres water depth. So we deployed 750 tonnes of loose culch, including 150 tonnes of scallop shell, tons of limestone, spread over 7,500 metres squared. We also deployed 10,000 loose oysters as well. oyster reef cubes with the aim of gaining a greater storm resilience with a slightly deeper site, around 25 metres in depth. So we deployed 20 oyster reef cubes, each weighing about 6 tonnes in weight, along with 40 tonnes of scallop shell culch and 4,000 mature native oysters attached onto those oyster reef cubes. And then in the middle of the cube array, we deployed 35,000 spat-on shell as well. We have gone down to start monitoring the site, and we have seen that there's some indication of adhesion issues of the mature oysters onto the cube, which we're looking into more as well. Is that video going to play? No, my videos aren't doing very well in this. Also, during that deployment, we tried a slightly different way of deploying the scallop shell culch, which is the image in the bottom right-hand corner, using a conveyor belt system that's usually used on mussel farms. So we trialled that there. I'm going to skip over this just in the interest of time and come on to our Conway Bay site. So at this site, we've been working to similarly deploy restoration activities, and by deploying limestone, gravel and culch materials. I think I reported this in a previous conference, but we previously used the method of using dumpy bags of limestone gravel, and unfortunately that led to an uneven distribution of the limestone gravel across the site. So we had to monitor and survey the natural redistribution of that material, and then excitingly this summer we managed to proceed with our activities by deploying some more scallop shells culch and 2,000 mature native oysters as a kind of trial. Here in the video you can see the scallop shell nicely making its way down to the seabed. And similarly at this site we're capturing key monitoring metrics to understand the development of the site as well. Here's some footage of the oysters and the scallop shell nice and neatly on the seabed, and a very happy Maria and Ree celebrating getting the oysters down there as well. I've got a QR code up here for a link to our reports for this site if you're interested in learning more, and also a bit of a shout out because Ree is doing a poster on our outreach and engagement for this site as well, if you want to go and learn more. And just finishing, so in our Welsh site, we've also got another project called the NNF3 Connecting Conway project, which is doing the groundwork needed to create a potential future seascape scale restoration project there. So as part of that, we're looking at doing habitat suitability assessment and feasibility studies. So we've been collaborating with modellers at Bangor University to complete habitat suitability assessments for Ostrea-Edgelis within the Conway Bay and Menai Strait SAC, and also completing targeted field surveys to ground truth those models as well, which we're currently been doing this summer. And then also we've been including some broodstock in the Menai Strait to test their survival for potential future work as well. So we'll be looking at their survival, growth, and also the environmental conditions in that location. So yes, thank you very much. That's everything from me. A quick whistle-stop tour of our activities that we've been completing. Thanks very much for listening.
Thank you. We have time for one question.
To present at this conference, so we need to spend a bit more time looking into it. Yeah.
Okay.
Sorry.
Thanks.
Thank you very much,
Thank
Céline. We invite you to go for the coffee break, and important to be back at 11:30. Please, to be in time. Thank you.
work no more. We've been here before. It ain't gonna work no more. Focus, your mind will be strong. No distractions, so called wisdom all year long. And then take action. I've been here before. It ain't gonna work no more. I've been here before. It ain't gonna work no more. I've been here before. It ain't gonna work no more. I've been here before. It ain't gonna work no more. Oh no 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 more.